Hello, and welcome to Desco's ESD Basics training. Today we're going to talk about, well, as I mentioned, the basics of ESD. We don't obviously have the time to touch on every single thing, but in this presentation, you'll get an idea of what static electricity is, how it's generated, and some or most of the things that you need to do to control it. My name is Greg Heckler, and I'm the Western Regional Sales Manager for Desco. So I'm going to be performing the presentation for you, as well as the demos that are coming up. So what is ESD? Well, we're going to talk about that, how it's generated. We're going to talk about the two different device models when it comes to determining how sensitive your electronic components are and how they can be damaged. We're going to also talk about the material types, the resistance of them, as far as the materials you need to use or the products you need to use to control ESD. Okay. So what is ESD? Well, it's defined as a sudden flow of electricity between two electrically charged objects caused by contact, and an electrical short or a dielectric breakdown. And so basically that's when a conductive object and a charged object come into contact with each other, and that's when we have ESD. And as far as these two symbols that are showing right now, these are typical static awareness or ESD awareness symbols that you might find on a sign on your wall, on a bench, on a cart, or something like that. These will alert you to the presence of static sensitive electronic devices in your environment. So how is static generated, or what is ESD? Well, static is generated by what we call Triboo-charging, or electrostatic charge generation. And that happens when two surfaces come into contact and then it separate. So as an example here on the right, this roll of Scotch tape. When I pull that piece of Scotch tape off, the two surfaces separate, some of the atom electrons move, and that causes an imbalance. So whether it's you lifting your foot off the carpet or pulling that piece of Scotch tape, those electrons are going to move. One of the surfaces gets charged positive, and the other surface stays behind negative or charges up negative. Both charges, by the way, can be damaging, but positive charges are actually more damaging, and I'll be explaining that in a minute. So again, one surface is always going to be positive, and the opposite surface is always going to be negative. So some examples of electrostatic discharge, or ESD. Lightning is a perfect example of ESD. So we often wonder what causes that lightning. Well, that's what happens when a cloud is full of rainwater on a stormy day, and a cloud happens to be, thousands of feet above the earth. And in many cases, it's very cold, so I could have water. I can also have ice crystals on that cloud. And when those rainwater drops or those ice crystals are contacting and separating, the top of the cloud becomes charged positive, and the bottom of the cloud becomes charged negative. So basically, to create an ESD event, I have to have, again, a charged conductor and another conductor or opposite polarities contact. So the positive ions in the cloud contact with the negative ions, and boom, I have a ESD event. And in this case, the positive charge, the lightning bolt, is looking for negative or earth, and that's why the lightning bolt comes to ground. Consequently, it's the same way with you. If your body is not grounded and you're walking across that carpet or vinyl tile floor, for instance, you'll typically charge up positive. You go to grab that metal doorknob or negative metal doorknob, and I have an ESD event, or I discharge the electricity from my body into that doorknob. So if you remember anything from this presentation, think about that doorknob as the conductive or the metal leads of your IC or electronic or ESD sensitive device. So that's a good example of that. So here are some examples of some of the charges we might generate. Walking across the carpet is very common. We all walked across the carpet and touched a doorknob and gotten shocked. So typically, maybe 1,000, 1,500 volts, in many cases, or some cases up to 35,000 volts. Walking across untreated vinyl flooring, meaning no floor finish or regular floor finish versus an ESD finish. Vinyl shop travelers, sheet protectors, plastic bags, regular polyethylene, things like that are big static generators, or what we call insulators. You working at your workstation, sliding back and forth in that chair, especially if it's a non-ESD chair on a regular floor. You can generate many thousands of volts just doing your job. Unwinding regular tape. I've already used this example, but tape is a perfect Triboo-charging mechanism or Van de Graaff generator. I have two pieces of plastic and I tear that piece of tape off the roll really quickly. And speed contributes to charge generation. Another thing that contributes to charge generation or keeps it lower is the amount of humidity or the relative humidity in the environment. The higher the humidity, the lower the charge will be. Consequently, the lower the humidity, the bigger the charge will be. So one thing to keep in mind is that depending upon the locality in which you live or reside and the time of year, you could have low humidity days and I'm generating a lot of static and I'm getting shocked a lot. Or if it's really humid, you're not going to feel as much charge or things aren't going to get charged up as high. So here's an example of an actual ESD event. This company, Hi-Rel Labs, specializes in field failure analysis of electronic components. And so if you were to have a bunch of failures or enough failures to warrant finding out what caused them, you might send these devices up there and they'll cut them apart, and with a scanning electron microscope, they can determine what the cause of failure is. And now that we have the models that I'm going to be discussing with you, they can determine whether it was an ESD event that caused that problem. When you feel a static charge, you had to have generated about 2,000 to 3,000 volts in order to feel that charge. If you see a charge like the one coming off this guy's fingertip, that's about 7,500 volts. So if you're seeing and feeling these events, you know that you're generating quite a bit of electricity. And nowadays, there are a number of components that are even sensitive to 100 volts and many in what we call the low class 0 range that are down in just a few volts of sensitivity. So the models, we have two models. And the first one and the most common one is what we call HBM, or the human body model. And that is when you have a charge on your body and your fingertip comes in contact with the lead of that device and induces that charge. So we see here by the diagram, we have a human body with a positive charge on it. The leads are all metal or another conductor, and they're typically negative. So again, opposites attract, and I induce that static voltage or that ESD event into that device. So the human body model is very common. And on that previous slide where I show the person damaging that device, that was a human body model event. And that has a specific signature look to it, or basically it would look like you blow a lightning bolt coming down and blowing a hole in the ground. The other model is what we call CDM, or charge device model. Now this is the opposite of the human body model. This is when we charge up a component or something like an insulator. Let's say I set my styrofoam coffee cup next to my ungrounded IC and I induce that charge onto that IC. Now I have a charged up conductor or component. And when I introduce that charged device to a highly conductive surface, for example, let's say I touch it with a pair of tweezers or a soldering iron tip, or I set it on a stainless steel work surface, or in many cases today, if that IC would become charged in a pick and place machine and it sits it down on the pads of the circuit board, now I have an ESD event. So that's what's called charge model. And just to give you an idea, charge device model is about twice as powerful as an HBM event. So we're concerned about both, and both of these can be identified and measured. So material types. There's two different materials basically that we're dealing with when we're talking about controlling ESD, or materials, for instance, that Desco might make to help you control these events. And one of those things are conductors. And most of us understand what conductors are, electrical conductors are. They're things that typically have metal, they might have carbon or something like that, that are electrically conductive, and they will allow current to flow across them. For instance, a copper wire or the traces on your circuit board. The human body is a conductor. What makes you conductive is the sweat layer on your body. The sweat contains salts and minerals, and so that's how that charge transfers from the sole of your shoe up and around your body and how it moves from your fingertip to that doorknob. So the good thing about conductors is that they can be grounded. So when we keep conductors at ground potential, not only will they not charge up, but if they have a charge on them, now I can ground that charge away. So it's very important that we keep conductors grounded. The other types of materials that we have are what we call static dissipative materials. And dissipative was a term coined not too long ago for controlling how fast we dissipate a charge from something. So for instance, an ESD work surface. We want to get rid of that charge, but we don't want to get rid of it so fast that it creates an event, like touching a doorknob. So an ESD work surface, for instance, the requirement is to have a maximum resistance of 1 billion ohms, or less than 1 times 10 to the 9th. That will safely dissipate the charge without causing an ESD event. For the human body, we want to be a little bit more conductive because we want to get rid of that charge as fast as we can without causing an event. So that is less than 3.5 times 10 to the 7th, or 35 million ohms. Flooring, you can be as high as less than 1 times 10 to the 9th, for instance, or you can be down in the conductive range. ESD flooring, we typically use to ground the human body, things like mobile carts, ESG chairs, for instance. When it comes to packaging materials, we're mostly concerned about these types of materials not generating a charge. So we can be as high as less than 10 to the 11th on those materials, because that will safely keep them from charging up too high, but will also dissipative charge should I set that ESD bag on an ESD work surface or something like that. So the range of static dissipative is quite large, as you can see, from 10 to the 4th to 10 to the 11th. So pretty much we have a horse for a course in this list here: work surfaces, flooring, packaging, etc. So basics of ESD control practices. The first thing you want to do when creating an ESD control program is to identify the area where your ESD sensitive products are. And we call that the EPA, or electrostatic protected area. And that could be a single workstation, it could be a whole room, it could be your whole building. But you need to identify that so you and your employees know where it is that you practice static control. The most important thing you can do is ground the human body. So we want to make sure that we're either wearing a wrist strap while we're seated, or we're wearing ESD footwear on a grounded ESD floor if people are walking around while they're carrying their ESD sensitive devices. Exposed static sensitive devices, that's when something is not grounded, okay? So we have different ways of dealing with those. If those exposed ESD devices aren't grounded, they either need to be sitting on a grounded work surface, or we need to keep them in static shielded packaging. And then we may have, then what we need to control are what we call insulators. Those are the charge generators that cannot be grounded. Those are the things like the plastic bags, the pink or the bubble wrap, the packaging materials. Let's say you make cell phones for a living and your plastic case of your cell phone. Well, you're going to put that circuit board right next to that plastic case that is generating a charge. So we want to be able to control those insulators, and we can do that a couple of different ways. We can get rid of them, we can move them far enough away where they're not a threat, or we can use ionizers to neutralize them, which I'll show you. And then packaging plays a big role as far as ESD packaging is concerned in a static control program. If I need to move, ship, store that ESD sensitive item away from ground, I want to make sure we're putting that in packaging that includes shielding, like those gray metallized static shielding bags or moisture barrier bags, for instance. And then compliance verification. Once I have all the equipment and materials I need in place to control static electricity, I need to test those periodically to make sure they're in compliance. I need to test my wrist strap every day, or my footwear. I need to test my ESD work surface, my flooring, my chairs, my carts, things like that. I can't just rely that those things are always going to be good. So I need regular compliance verification for those. So what I'm going to do right now is I'm going to do a number of demos for you. I'm going to demo what I consider, or what we consider, insulators. I'm going to show you the test equipment that we use. I have a charge plate analyzer, which I show you. I'm going to demonstrate how we neutralize insulators. And then I'm going to explain what we call the 12-inch rule and the 1-inch rule. And I'm going to talk a little bit about personal safety when it comes to grounding the human body. Just give me 1 second. Okay, so I'm going to come over to here to my workstation here. I have a few things. I have my ESD survey kit here. Desco makes a kit that contains most or all of the equipment that you will need to test your static control program. It doesn't contain a wrist strap tester or something like that, but as far as compliance verification for work surface, I have a conductive floor down here that I'm going to be standing on. I have an ESD tote box. I have things like this, and I have insulators here that I can demonstrate how you can measure all these things in your static control program. So I have my surface resistance meter. I'm going to show you how to check your ESD mat as an example. I have what's called a static field meter. Okay, you can see my static field meter. Now keep in mind that I can't measure a static charge on something or voltage on me on a piece of plastic with a regular voltage meter by putting my 2 probes on it. Static field resides on the surface of it, and it's basically like a halo sitting off your body or on that piece of plastic. So you need a static field meter to be able to do that. I also have what's called an ionization test kit. When you combine this hood to my static field meter and a charge generator to put voltage on this hood, now I can use this equipment to test my ionization. I have these paddles that Desco has developed, a solid piece of acrylic and a solid piece of aluminum on a piece of acrylic. So this represents that plastic bag, that cell phone case. This one represents an uncharged conductor, you not wearing your wrist strap, or an IC sitting upside down on your ESD mat and the leads aren't touching that IC. Any conductor that's not grounded, all right? And then I have what we call a charge plate analyzer. This is probably the most sophisticated piece of equipment you would have in your static control program. This is primarily, you would purchase this equipment to calibrate ionizers, but you can use it to measure charges, all kinds of things in your static control program. I have some other examples. I have a non-ESD or a regular non-ESD, what we call a Menda bottle here, a chemical dispenser. I have an ESD version. I have some ESD bags back here. I have a regular reel from a tape and reel. So I'll give you an example of some typical things that we would use. So I'm going to start with surface resistance on my ESD mat. So I have this 5-pound weight, which they come with. This kit comes with 2 different 5-pound weights. This is our digital 19290 surface resistance tester. I have my other black lead. It's attached to ground here. My ESD mat is attached to ground. So basically what I'm going to do is I'm going to press the button, and our groundable surfaces need to be less than 1 times 10 to the 9th. So as you can see, we're looking at 1.5 times 10 to the 6th. So that's well within spec. So the importance of this is, 1, I know that it meets the manufacturer spec. I know that it meets the ESD Association standard specifications. And I also know that if I put a grounded conductor on this, it's going to ground that device. And if it has a charge on it, it's going to safely bleed that charge to ground. So that's the importance of this test. So whether it's an ESD chair, an ESD cart, my flooring, whatever it is, you need to know what the surface resistance of your groundable materials are. So now I'm going to show you what we can use the static field meter for. This is typically used when I want to walk around my environment and I want to test to see if I have any things that generate a charge. Now there are 2 rules when it comes to insulators. I mentioned this before, the 12-inch, what we call 12-inch 2000 volt rule, and the 1-inch 125 volt rule. So let's say I have this reel in my environment and I want to know if it's okay to use. And so if this reel would generate more than 2000 volts, I need to keep it more than 12 inches away from my part. If it generates more than 125 volts, I need to keep it more than 1 inch away from my part. That, though, is something I can move. In the case of this reel, though, I can't move it. My ESD parts are going to be right on it, if you will. So this is what we call a process insulator, a process required insulator. This thing also is a static generator, but I can just buy an ESD safe version of it. So I can get rid of that and buy the ESD safe one. So there's non-essential insulators and there's process required insulators. So we use our field meter to measure those insulators. So I mentioned these paddles here. So what I'm going to do, I mentioned that to generate a charge, I need to have contact and separation of these insulators. So I have my acrylic piece, okay? I'm going to look on there. And so I'm going to bring this one over here. And you can see that I'm putting, let me look here, I'm putting about 3,000 or 4,000 volts on that. Now, notice to the left of that test, there is no symbol there. Now I'm going to show you what happens when I generate a charge on a conductor. So now I'm going to come back here, and I've got about 5,000 volts on there, but notice there's a minus sign. So that plastic was positive, this conductor is negative. Again, one will always be positive and one will always be negative. Now the difference here, this plastic paddle's been sitting on my ESD mat. Did I ground it? No, you cannot ground an insulator. So you can't take your water bottle and just set it on your ESD mat or your coffee cup. You either need to get rid of it, I need to buy an ESD safe version of this, or I'm going to show you ionization, you need to neutralize it with an ionizer. Consequently, I set my metal paddle on here. Is there a charge on there? No. I safely grounded that charge away. So again, no matter how you think of your IC, whether the doorknob or the metal paddle or whatever, conductors can be grounded and insulators cannot be grounded. Now I'm going to show you one to give you another example. I have my charge plate analyzer here, and I'm going to show you, if I hold this field up there right now, the charge plate analyzer is rating a little over 1,000 volts, something like that. Again, I'm going to charge this up, and I'm going to show you let me ground this away here, zero it. So I'm going to touch this. Now I have 800, almost 900 volts here. Again, the difference is, I'm going to ground this away. I can ground the conductor. Notice how there's no more charge here, or very little. I cannot ground the insulator. So it's very important to understand that, all right? Now I'm also wearing 1 foot grounder. Okay, so let me show you something else. I'm going to ground up this. I'm going to hold my foot up off the ESD floor here, all right? I'm going to hold this conductor in the presence of the charge plate analyzer. Now I'm going to touch it, and you'll see that charge drop down because I also ground it with my body. So it doesn't matter what the conductor is. It could be me, it could be the mat, could be an ESD safe cart, something like that. When I set that conductor on that surface, it's going to safely ground that charge away. So I'm going to show you now how we work with ionizers, for instance. So let's say, or let's pretend that this plastic paddle is the case of plastic case of my cell phone. A cell phone's only that thick. There's no way I could keep that circuit board more than 1 inch away from that plastic cell phone case. So that's now a process required insulator. So again, I'm going to charge this up. I'm going to show you that I got a charge, but now I'm going to hold it in the presence of this ionizer. And I come back here, and you're going to see that it's knocked the charge down. It's got 3 volts on it, which is negligible. It's the same thing with conductors. If I'm not grounding this conductor, it can also hold a charge. So I can show you real quick how I put that charge on it, but now I'm going to hold that conductor in the presence of the ionizer. And again, I've knocked that. Oh, I got to zero my plate. Hang on one second. Let me do that again. So I'm going to charge this back up. I'm going to hold it in the presence of the ionizer. And I'm going to bring this back over here. And you can see that ionizer knocked that charge off. So one of the great things about ionizers, or a couple of things, is one, they help keep things from becoming charged up, but they remove charges on insulators and they remove charges on conductors. Now, another important part of your static control program are ESD garments. And what ESD garments do is they act like a static shielding bag for your body. So instead of keeping charges in or keeping charges from getting in, they help keep the charges on your clothing from getting out. And why that might be important would be an example like this. I have this ESD safe tray full of printed circuit boards here. So if I was wearing a wool sweater in the wintertime, for instance, and I was walking across the floor with this tray, I would induce the charges from my clothing onto these circuit boards. Or in other words, I would be violating that 12-inch 2000 volt rule or that 1-inch 125 volt rule. So what ESD smocks do, especially a good one like this that's very conductive, is they act like a ESD bag to keep the charges from your clothing getting out. So that's a perfect example of a smock. The other thing we can show you too are ESD packaging materials. And I talked about, or I used the term static shielding. In order to have shielding versus say a pink poly or an anti-static bag, you have to have conductivity or metal of some kind. So when it comes to static shielding bag, we have a dissipative outer layer, we have a dissipative inner layer, but then we have a metal layer of aluminum on the inside. It's that aluminum that keeps the charges from getting in that bag. So again, I'm going to go back to my paddles. Shut my ionizer off real quick here. I'm going to go back to my paddles. I'm going to charge this plastic one up. I'm going to measure this plastic paddle. I've got about 4,000 volts on it. Now I'm going to put this paddle inside my shielding bag. Okay. Charge is still there because remember, you can't ground the bag or you can't ground the plastic paddle. Now I'm going to bring this back and you're going to see I'm not measuring any charge at all. So shielding bags do two things. They keep charges from getting in and they keep charges from getting out. So it's very important that if my printed circuit board, my ICs, whatever my static sensitive devices are in or on, that they be grounded, or if they're what we call exposed, that they be shielded. Very important. Okay. Other types of ESD packaging. Sometimes I just need a piece of material that won't generate a charge. And that might be when I'm trying to control paperwork, documentation, things like that. The problem with paperwork is if I set my printed instructions down on my work surface and I set my ESD device on my paperwork, it's not grounded anymore. Also, regular sheet protector shop travelers generate a charge. So I want to make sure I got packaging that won't generate a charge. So for instance, I'm going to rub this one on my pants. I'm going to put it up here next to the charge plate analyzer, no charge. I can show you this also on the static field meter, no charge. So you want to make sure that anything that comes in contact within 12 inches of that device is a low charging or a static dissipative material. So it's very important that you understand that. And so those are pretty much the basics of ESD. We can get more in depth later. If you want to contact us, I'll put up my contact information to contact me. But we're talking about, again, grounding all conductors, removing insulators that we can, and if we can't, we want to either buy that thing we need to be protective, ESD safe, or we want to neutralize it with ionization. Now I want to show you one other thing too. There's a safety aspect of ESD control. Many of you know that inside your wrist strap cord, there's a 1 megohm resistor in there. When I am grounding my human body, I'm attached to the electroground ground. In this case, I'm plugged into a continuous wrist strap monitor, and that monitor is going back to the AC ground through its power supply. So if I were just to wrap a copper wire around my wrist, I would be hard grounded. If we got hit by a lightning bolt or that ground became energized, I could get shocked. So all of our products contain 1 megohm safety resistors that keep the human body safe or protected up to 250 volts. So one of the things that this monitor does, it will tell you whether you're meeting that minimum resistance requirement. Now I've got another cord here. This cord has a red molded head on it, and it's important to understand that the standard requires that if I don't have resistance in something, that I identify it with a red color. So that's what we've done here. This cord doesn't have a resistor in it. So I'm going to unplug this one. I'm going to put on my red-headed cord here. I'll plug back in. And this monitor has about an 8-second delay in order for some circuitry to work. So we'll give it a couple more seconds. and you're going to see that I'm alarming now. With my resistor cord, or with my cord with a resistor in it, I was safe. With this with no resistor, I'm not safe. So there's other ways we can identify that, but that is one of the nice features about. Now notice it stopped alarming. That's because I'm wearing an ESD or a conductive foot grounder, and now I'm standing on my ESD mat. So there's a number of ways we can control static, whether it's through the wrist or through the feet, and ways that we can identify that we're in spec, and ways that we can identify or make sure that our personnel are safe. So I want to thank you all for coming. We appreciate it. Hope you learned something today, and we'll put up my contact information here. Just 1 second. See my screen? You me? You seeing that now? Okay, so you're seeing my screen. So again, my name is Greg Heckler. I'm the regional sales manager. There's my email address, my phone number, and oh, sorry, email address, phone number. I want to thank you for your time. And again, contact me anytime you like. I'd be happy to address your questions. Thank you very much.